right, so yesterday we did through right triangle trigonometry pretty quickly because it is a review, right? Did it in geometry. It's not a brand new thing. So you need to know how to solve these right triangles, know how to, decide whether it's sine, cosine, or tangent, that sort of thing. And then for the applications, you got to be able to draw the picture right, because y'all are good at trig. It's for the right triangle trig is pretty easy. If you don't get your picture drawn and labeled right, you have no hope. Yes. Did I not give you? I did not, because she was back there. I'm sorry. All right. This is going on 108 when we're done. The application problem, sometimes there's a picture drawn for you, but sometimes there's not. But a lot of times we'll talk about angles of elevation. Okay. And it's very likely geometry kids right now. The key to angle of elevation and depression is this. In order has to be, one of the two sides has to be a horizontal line. So before you can create the angle, okay, if you think about looking at something, it's not always a person that's looking. It can be coming from a rock or from the ground or whatever. So you look straight ahead, it's horizontal, so it's parallel to the ground. And then from that, if you look up, that's an angle of elevation. That should make sense, right? Or from the horizontal, if you look down, that's an angle of depression, right? Most of the time, angle of elevation is not what you mess up on, even if you're not really thinking real hard about it or paying attention to it. Usually that one gets right. It's the angle of depression that is likely for you to be able to draw it wrong every single time. So here's what goes next. So an angle elevation is an angle formed by a horizontal line. That horizontal word is so important. Horizontal line, a line right to a point above the line. And then an angle of depression is an angle formed by a horizontal line and a line of sight to a point below the line. It's that simple. So there's really nothing hard about it, but I do see it done wrong, like a lot. So here's what a little picture we're going to draw here. Just draw a little person. Okay. And he's looking sideways, okay? And then he's got a horizontal line, right? So that's your on a line. So basically, look straight ahead. Then, when he looks up, that right there is your angle of elevation. Okay. Angle of elevation from the horizontal when he looks down, whatever. This right here is your angle of depression. Everybody good on that? It is helpful, even if you know in the end that your picture is going to be a triangle. If it's not drawn for you, you drawing a triangle and trying to stick labels on it, it's probably not the best idea, because I think that's where the mistakes come in a lot. If I have a right, I do not have an angle drawn on that picture. Not yet, anyway. The things that people do wrong is try and put it right here. That is not your angle of depression. This will never be an angle of elevation, because there's not a horizontal line with it. Does that make sense to you? Okay. So if I need an angle of depression and I already have my triangle drawn, then I have to do the horizontal, and then I would look down that right there. Is that congruent to an angle that's in the triangle I already had? Yes. Is it congruent to this one? No. If I know this angle, can I figure this one out? What do these two have to add to give me? 90. Don't subtract and find this one. Because of all the hard stuff y'all can do, you subtract from 90 wrong. So don't do it. It's not worth the risk. If it's congruent, that makes it way easier. So this angle is congruent to this angle right here. bonus favorite student points for anybody that can say it. Oh, Katie Fan is my favorite student. Alternate interior. Okay, because these lines are parallel because they're horizontal. These are alternate interior angles because that is your transversal. That's why they're congruent. Good job, Katie. But even so, I could use this angle in this triangle if I wanted to. Doesn't matter. But here's that. Okay, all good? So let's look at this picture, or let's look at this problem. It says the altimeter of a jet. How many of you have no clue? Probably, yeah. Let's keep going. The altimeter of a jet at O'Hare Airport in Chicago reads 5,900 feet. Okay, so it's not an angle measuring device, right? You can kind of deduce that. As it passes directly over the Sears Tower. At the same time, the angle of depression from the plane to the end of the runway is 5 degrees. How far is it from the base of the Sears Tower to the end of the runway? Okay, so here's the Sears Tower, end of the runway, here's my plane, right? So I'm looking for, it says, how far is it from the base of the Sears Tower to the end of the runway? So this clearly is what I'm looking for. I'm going to call that X. This is my right angle. Even if this is like a building or something or a sign and you don't know that it's perpendicular to the ground, it doesn't matter because the height, that distance is always measured perpendicularly, even if the thing itself is not perpendicular, okay? And then it says the angle of depression from the plane to the end of the runway is 5 degrees. So is this right here 5 degrees? No. My angle of depression is right here. This is 5 degrees. So you've got some options. You can use the triangle drawn for you, which isn't always going to be drawn for you. You can create what I call an upside down triangle, even though it's not upside down because there's not a right way. But I could use they don't have lines straighter, even though that's this is X. Then I have to go back and think about this altimeter. So the altimeter of a jet, because you have things sometimes. Except for I don't even know what that thing is. So I'm pretty sure it's options here since I'm looking at this piece is either it's going to be the hypotenuse, which would mean it's the actual distance from the plane to the runway, or the height it is above the ground. What is more likely to be the case? The height above the ground. Like that makes more sense as that would be something that they're measuring, right? And that is what it is, but if without me telling you that, some of you may not be confident that that's really what it is, but sometimes you just have to reason through and decide what makes the most sense, okay? So that here is your 59,000 feet. So I usually prefer to go ahead and use the bottom triangle. I think a lot of people, because that has more labels on it than this one, but it doesn't matter either way. It's whatever makes the most sense to you. So, but I can take that. Yes, I can figure out what this angle is. Don't do that, even when it's easy to subtract, because you don't want to risk it being wrong. It's way easier just to say, I know for sure that's 5 degrees, because they're congruent. So now that you have that label, right triangles, I can do Pythagorean theorem. It's trig. If you have trouble with what the opposite and adjacent is, Mrs. Archer called me yesterday and had some of my former students in there that were claiming that they never understood what opposite and adjacent were, or were never taught that or something, I don't know. And so she called him out on it. It's like, no, we know how to do this. So not all of you need to draw the arrows, but if it's foggy for you or you never really got it, draw the arrow. Here's the angle. That is the side that is opposite to that angle. The hypotenuse is across from the right angle. You've known that for like ever. And so I don't care about the hypotenuse. It is, and they didn't give it to me, so I'm not using it. This, what do I label this side as? Adjacent. Okay. And then what really should be at the top, either at the top of every paper that you do trig on, or at least in your mind. Again, you need to write it at this point, but you at least thinking it. What's my acronym for trig? SOHCAHTOA. SOHCAHTOA. And if it's not something that's already ingrained in your brain, the more you write it, the more likely you are to spell it correctly when it matters. Right. So I'm using opposite and adjacent. What ratio is that? Tangent. So I'm going to take the tangent of what? What do I take the tangent of? 5. It's 5,900 over the adjacent, which is x. So what is when I solve for x, what's it going to look like? 5,900 over the tangent of 5, right? Because when the variable's in the denominator, they just switch places. So x equals 5,900 divided by the tangent of 5. You have to have something set up. You cannot just have an answer, type everything in your calculator. Like, you don't have to write any intervals down or anything. So I get 5,900 divided by the tangent of 5. I get that number. 67,000 something. Anybody get anything different? Anybody initially different than that and then realized they weren't right? Okay, what did you get? What? Just tell me what. It was a negative number because the mode was wrong. Yeah. So when you're in radian mode, but you're using degrees, sometimes remember you get like wacky answers that are negative that you know can't be right. So you're like, oh, okay, I got to go check something. Something's clearly wrong. But sometimes it works out to where the answers don't seem so unreasonable, or if they're not negative, you don't even think about them being unreasonable. So always check that mode. And right, so then here, x equals 67,437. Point what? 309. What are my units here? Feet. Okay. So I called it x so that we had something to call it. You can call it whatever you want. But nobody asked me to solve for x. So I actually haven't answered the question. I just said this is x. Nobody asked me for x. It says how far is the base from the base of the Sears Tower to the end of the runway. So what this is the distance from base of tower to end of runway. Math, getting answers, you're not always so great on what the heck the number you just got means. So you got to make sure you're answering the question. Okay? Abbreviating is fine, but you got to identify it. We all good? Okay. Number 2, I want you to read that question and draw it. So we need to talk about, yes, sir. We need to talk about the picture. Okay. It says you must order a look at the words anymore and draw me a perfect picture. So here's my flagpole. And so here's my flagpole, right? And if your flagpole is on the other side and your triangle's flipped around, that's totally fine. And it's going to create a triangle. I'm going to go ahead and I'm going to kind of do this the way, not the way I would necessarily do it, but the way that a lot of people do it, and then things get confusing. So there's my flagpole. It amazes me that we have no clue, where a shadow goes. I'm making a shadow on the board right now, but nothing. Right. So this is my shadow. It's 11.6 meters long. Now, the other thing that just baffles me is that I have students put the sun over here and get very confused about where the angle goes. What they're really confused about is what creates a shadow, right? When you're outside, what's creating the shadow during the day? The sun, right? Yes, any light source can create a shadow. That's why I'm making one now. But when we're talking about the sun, the reason this shadow exists is because this flagpole is blocking it. So the sun being over here makes no sense. So this hypotenuse, if it keeps moving, it hits the sun here somewhere. So the angle of elevation to the sun, do I have a horizontal where I could draw an angle of elevation? Here's my horizontal line. This is my angle of elevation. Okay. May not seem that difficult, but wow, do I get strange things on these. Just want to make sure we all understand shadows. Okay, so that now I've got this angle. So x is what? Opposite, adjacent, or hypotenuse? Opposite. And 11.6 is adjacent. So which trig ratio is this? Tangent. Okay. So if you need to write SOHCAHTOA at the top, do that. Tangent of what? 36. Bless you. Equals the opposite, which is x, over the adjacent, which is 11.6. So do I switch the x and the tangent of 36? No. In this case, multiply to solve just like I would anything else. And I get x equals 11.6 times the tangent of 36. So then I get that x equals 8.428. Y'all agree with that? Okay, so then that's x, but what it says how tall is the pole? So I can write a sentence and say, you know, the flagpole is 8.428 meters tall, but at this point, I'm okay with you just giving me some words at this point. So 8.428 equals the height of the flagpole. Because my guess is, I made you use words in geometry. You probably didn't have to use a whole lot in Algebra 2. We really should be doing a whole lot more with that than we are, because when you get to calculus, it's going to have to happen. So I don't want it to be like the first time you've been exposed to that. We good? All right. So from a point on the north rim of the Grand Canyon, a surveyor measures the angle of depression of 1.3 degrees to be measures an angle of depression of 1.3 degrees to a point on the south rim. From an aerial photograph, he determines that the horizontal distance between the 2 points is 10 miles. How many feet is the south rim below the north rim? Okay, so what I didn't realize until I started looking through these notes is I grabbed some angle of elevation and depression problems out of something I found in one of the files that I had to make a worksheet for my geometry class, and this exact problem is something that they're doing. So what I found interesting about this when they were drawing it is a lot of people's drawings looked very different from each other, but they all got what they needed out of the problem. So if you don't really understand what the south rim and the north rim is, hopefully you at least understand that the Grand Canyon is a great big hole in the ground, right? Okay, and that if you have an angle of depression from one thing to the other, are they the same height? No, they're not. And so whatever it is, whatever it looks like doesn't matter, because this isn't an art project. You just have one thing that's below another thing, and that's all that really, really matters. So you don't have to draw the Grand Canyon or anything like that. So we'll go back to the measures an angle of depression 1.3 degrees to a point on the south rim. So here's going to be the ground. So here is the one that's taller. Here is the one that's shorter. Okay. So from here, this point, they can see this point at an angle of depression of 1.3 degrees. So he's looking like this. Do I put my angle right here? No. What do I have to have for an angle of depression? Horizontal line. So I would have to look straight ahead. Then I get to look down. See that? That's my angle of depression, and that is 1.3 degrees. This down here is a trapezoid. But if I finish this off here, since this was horizontal, this is a right angle, I've got a little right triangle up there. And it says the horizontal distance between the 2 points, not the distance between the 2 points. Make sure you go back and yes, you're reading it a piece at a time. If I ignore this word and just read the distance, that's the hypotenuse. The horizontal distance would be this leg. Make sense? Because it's easy just to glance up there and pull it out. So this is 10 miles. And so I want to know how many feet is the south rim below the north rim. So I'm looking for this right here. Now, what do you notice about the question part of that? How many what? Feet. And this distance is in 10 miles. So let's be honest. Most of you aren't going to notice that at first. So you're not going to convert first because you didn't even half read the question, right? You're going to work it in miles, and then you're going to say, oh, that answer's weird. Then you're going to realize you have to convert, right? Some of you will read it and convert first. But most of you rush through things and you don't. It doesn't matter if you convert before you do it or after you do it. Just as long as you know what you're getting when is fine, okay? But in my experience, you're just going to work the problem and think that you're done until you go back and hopefully read it. So we'll just go with this. This is angle, so this is the opposite, and this is the adjacent. So once again, I'm using tangent, right? So the tangent of 1, opposite, which is x, over the adjacent, which is 10. So that means that x equals 10 times the tangent of 1.3. Okay, so let's do that. 10 times the tangent of 1.3. And I get 0.2269, blah, blah, blah. So I get 0.227. Then when you think, oh, I have to have units on my answer, the units are in miles. When you go back and reread the question, which you should always do, but probably don't always do, it says how many feet. Now, regardless of all of that, does this answer make you think something is a little weird anyway? Yeah, it does, because it's like, wow, that's really small. Maybe I'm in radians. I'm going to go check my mode. But reasonableness of an answer is important here. This is, even if my picture is more to scale than they usually are, I don't even know how I lucked out with that. But this angle right here, 1.3 degrees, is a super tiny angle, which means the side across from it is super small relative to the other two sides. Does that make sense to you? So if this is 10 miles, and this is only 1.3 degrees, that's just a tiny little degree, then this is just going to be a tiny little bit compared to this number. If you think about this in miles, that's just a little less than 1/4 of a mile, which is still kind of far, right? I mean, it's not like that's not like a couple inches. That's still kind of far. It just seems weird, so once you think through reasonableness, you're good, right? But now I need to convert. How many feet are in a mile? 5,280. That's something you need to know, just like life in general, one of those things, just commit it to memory. Do I take this number and multiply it by 5,280? This particular number right here? No, you do not. You take the value of this, which is still in your calculator. You don't necessarily have to store it. At this point, you can. But if it's the last staring at you in your calculator, you just do times 5,280. Oops. I don't know what happened. 80. And that gives you your answer right there. Then let's talk about rounding. 1198 point what? 200, because those zeros tell you there's something else out there. That's feet, right? So that is, let's see. We'll say difference in height of north rim and south rim. There's other ways you could word it, but I was trying to use as few words as possible. That'll work. Everybody good with all that? Any questions? All right. Next one then. An observer 8 feet above the surface of the water measures an angle of depression of 7.7 degrees to a distant ship. He measures the angle of depression to a second ship at 4.2 degrees. How far apart are the two ships? Give your answer in miles. All right, so he's in, and there's an observer 80 feet above the surface of the water. So here's my water. He's 80 feet above. I don't know what he's doing. I don't know if he's floating, what's happening, but it doesn't really matter. So he's up here. This is 80 feet. Not 80. So he sees two ships out here. There's one ship. There's two ships. Okay. One he sights at an angle of depression of 0.7 degrees, and one is at 4.2 degrees. Which one is the furthest out? Which angle would go with that one? One thing. The 0.7. Because the farther something is, if you think about looking straight ahead, you have to look down, right? And the closer it gets to you, the bigger that angle of depression gets until it gets to 90 at your feet. So if you look at this one, look at it, but this is, it looks straight ahead. This is 0.7 degrees. Then he looks straight ahead. The second ship. So from here on here, that's your 4.2 degrees, which clearly my picture is nowhere close to being to scale, but it really doesn't matter. It's fine. So what I'm looking for is the distance between this is the side of this triangle right here. Are we capable of doing trig on that kind of triangle just yet? No, we get to that at Christmas, but that's not a right triangle, so I can't do trig on that. Find it directly. But do I have right triangles in my picture? Yes. Okay, so I have this right triangle right here, and I have this bigger one right here. I'm capable of finding this part, which I'm going to call y, and I'm capable of finding this whole thing down here, which I'm going to call z. Now I also need to angles to these triangles. So what's this angle right here? Anybody know? What's this one going to be? 4.2. This is the 4.2 angle. This is not to scale at all, so look at angles. And this is the angle here. Everybody good? In the end, I'm looking for x, right? X is just going to be equal to what in terms of this stuff? How do I find x if I know y and z? Z minus y, right? Which means when I find those things in the calculator, store them, yeah, because we don't want to use the rounded answer. All right, so we'll start with these angles. This is the opposite side. For both angles, this is the adjacent side, right? It's not the only ever used tangent. It's just what comes up in a lot of these. So the tangent of 4.2 is equal to the opposite, which is 80, over the adjacent, which is y. So y equals 80 divided by the tangent of 4.2. Everybody good with that? So we can go ahead and in the calculator. I already know that I want to store it, right? You can do this all in one step. I know a lot of times we get the answer and then we store it, which is fine too. But at this calculate it in y form all in once. And this is what I'm going to do. I'm going to write down, this was y equals 10 point, not 10 point. Was it 1089 or 1098? Okay, so I'm at 1089, but I'm going to put like a dot, dot. If I actually write a number there, I'm more likely to type it back in, which I don't want to do. But I do want to have an idea of what it is in case I get confused or sidetracked or whatever. So there's my y. Find z. So for that, that's tangent. So now it's the tangent of 0.7, and that's 80 over z. So z is 80 divided by the tangent of 0.7. 80. And that's 6547. That way I know when I get my final answer, if it's something like way off from, 6,500 minus about 1,000, that maybe I didn't store one of them or something happened. You don't actually have to store either one of them because you can just, if you type everything and it's not super crazy, you could do it all in one step with your exact. I really like doing that. I know to find x, I just that's what I get. Okay. So 5458. And as soon as it disappears, I completely forget. 0.371? Okay. 0.371. What are my units here? Am I done? No. It says, how far apart are the two ships? Give your answer in feet and miles. So if this is my answer in feet, what do I do to it to get it in miles? Divide by 5,280. And it's already in my calculator, so I don't divide that. I divide this. which is 1.034. So both of those are my answers. And the distance between the ships. Any questions at all? We're good? All right, so we don't have time for the last example, but because I am playing with phones, I'm going to make a separate video of just the last example. So if you want to see it and you feel like you need it, it'll be there because it won't take very long. But we just want to class.